Okay, so let's do the second problem. What do we have here? Aliou Cafe, which is the cafeteria at our campus. They sell very delicious croissant in the morning. And of course, you know that croissant is one product that's better to be consumed when it's very fresh because it really loses its taste very, very quickly. I agree with that here. Okay, so if they do that, any leftover, okay, so after 1 hour, um, they cannot sell these. Okay, and you can see that this comes in our first question, that how many they have to make if all unsold croissants are trashed. Okay, so they are making here a good decision not to sell them anymore. So it costs $1.2 to make one croissant, and they sell it for $1.8. Here, we are told that demand is estimated to have an average of 150 and standard deviation of 30. Okay, what I'm missing here, in fact, that the probability distribution. Okay, so let's assume that demand follows a normal distribution. Okay, so take that to be given. So it has a mean of 150 and a standard deviation of 30. Here we go. I'm sorry about this. Okay. So how many croissants we have to make? So obviously this is a single period model where we can sell during the single period of 1 hour, right? So we need to find the optimal service level that comes from the stockout cost and the surplus cost. So let's find these. Stockout cost is how much we're going to lose in profit, right? If you run out of croissant and there are people asking for it, you just lose the profit that you could have made. And what the profit? This is very basic. It's equal to the price minus the cost. So that's 0.6. What about the surplus cost? Given that everything would be trashed, you see here, okay, so I don't have any salvage value, which means what I'm going to lose, let's say we are left with 12 croissants unsold. That's it after 1 hour. So we're going to trash them. So what do we lose? We lose their production cost, right? We don't have any salvage value here. It's zero because they are discarded. So that makes our surplus cost 1.2. Service level now, it's very straightforward. It's simply the ratio of surplus stockout cost divided by the sum of stockout and the surplus, and that's 0.33. So what does it mean? That means it's optimal for us given the structure, the cost structure of surplus and shortage. Okay, and we can see that here the heavy weight is on the surplus. It's 1.2 compared to the shortage of 0.6. What does it mean? That means I'm always willing to have a shortage than to have a surplus, because it costs me much less to have a shortage than to have a surplus, and that explains why it's optimal for us to serve only 33% of our demand. This is optimal. All right. Now, from that, what do we have to do? We need to find the z value. Okay, and we look into the z table such that the probability of z less than a certain value that we are looking for, we call it the critical value, or z star, 0.33. So here we go. This is an extract from the z table. We want to look inside the z table for 0.33, right? Because what's inside the table is the probabilities. And looking carefully, we can see that we have exactly the same value, 0.33. So what's the corresponding z value? We look in the same row and we see minus 0.4, and this gives us the first decimal for the z. And then for the second decimal, we look into the same column and 0.04, which means our z value is minus 0.44. Now we plug this value in the formula, q star equal mu plus z star times sigma. Mu is given as 150, sigma is 30, and minus 0.44 is our z value. and we get 137 units. So you see here what we're doing. We are making a quantity which is less than the average, right? Because there's a heavy weight on the surplus. So this will be our optimal quantity. Okay, now here they are telling us that unsold croissant will not be trashed anymore. Okay, they can instead be sold as semi-fresh items, but of course for half the price. It's very fair to do that. So in this case, how many croissants should be prepared? What do you think first? Before you, I advise you to pause the video and think about it critically, honestly, and just come out with an answer. Would do you think the quantity now will increase or decrease? All right, let's see. First, to discuss that logically, what do we have to do? When we can sell all left over for half the price, what's that? We are salvaging part of our cost. So we are not losing all the production cost, which means now this will give more balance, or sorry, more weight in this balance between the stock out cost and the surplus cost, which will now give us some motivation to take more risk. All right, which means that we're going to have a larger quantity. So let's do the calculation to support this theory. Okay, the shortage cost does not change, right? Nothing changed in our cost structure. So it's still price minus cost. So that's 0.6. Now what changes is the surplus cost. Now I have a salvage value equal to what? It's half the price that I used to sell, which was 1.8, right? That was my full price. Half of it is 0.9, and this is my salvage value. And now this makes my surplus cost 0.3. It went down from 1.2 to 0.3. And now you can see that it's more beneficial for us to have a surplus than to have a shortage, right? Because this is heavier for us now, 0.6 compared to 0.3. All right, so let's find now the service level. And you can see now it's 0.67, which supports what I just said. Now it's better for us to fulfill 67% of the demand. All right, so it's higher than the average, higher than the 50%. Based on that, we need to find now the Z value. Again, we look in the Z table. I'm not going to show you again. By now, I'm sure you are familiar with it. And you find the value to be 0.44. Plugging this value in this formula, we get Q star to be 163 units. Okay, so that supports our theory that we came out before we started our calculation. All right. Now, if the quantity, if this 163 units that we found to be optimal is indeed prepared, okay, what would be the probability that all croissants will be sold? Think about it. In which case we can sell all what we prepared? It's not hard. But remember, demand is probabilistic. So demand can be at any value. And that's what makes that a probabilistic value to find. That's why we're asking what the probability that we can sell everything. The probability that we can sell everything if demand was equal to that 163 or more. So for example, if demand is 164, so we sold all the 163, right? And we have a shortage. If demand is 165, again, we are able to sell the 163, and two students would leave sad because we could not satisfy their demand, etc. And that's why I can write that probability that selling all croissant is equal to probability that demand is greater or equal than Q star. All right, which is what? It's 1 minus probability that demand is less or equal than Q star. And why I'm happy to see that? Because this is my service level that we just found. So it's 1 minus 0.67 that we got here. Okay, and the probability that we can sell everything is 0.33. Okay, so I hope that was clear for you.